Okay, today's lesson is on the introduction to evaluating and solving logarithms. We will be keeping it rather basic just to get your feet wet, so to speak, and ease into this concept. So first, let us recall that logarithm functions will always be the inverses of exponential functions. So we just finished going over the content of graphing log functions and exponential functions. And if you recall us drawing exponential functions, they reflect over the y equals x line to become the logarithmic function. So they're inverses on one another. What we're going to do is start manipulating being able to write a log function into an exponential function and vice versa. And we need to first cover how to rewrite these based on what you're seeing down below. So the log b of n is equal to a is read as log base b of n equals to a. Now, what I want you to notice is that the subscript here of log will always be the base value. And notice that base value is b over here in our exponential. So our exponential b, whatever that number is being raised to a power, that will become your subscript in log. Next, I want you to notice that the exponent of your exponential is what your log will always be equal to. So what I always tell students to remember, if they can remember this phrase, basically a log or a logarithm is an exponent. If you honestly can always remember that, it makes the writing of logarithms and exponentials so much easier. Because if you notice here, I'm telling you that a log is an exponent here, okay? I'm actually telling you that. So here's your exponent, and I'm telling you a log is an exponent. So whatever that number is for an exponent, that's what your log is always going to equal to. Last but not least, we will have our power. So whenever you raise a number to a power, you're going to get an answer. That answer will always go in this position, okay? So no, you just need to figure out how to memorize this. And one way a lot of teachers do is they want you to notice that when you're rewriting log, you go like in a circular motion. You start with the b right over here, and you circle over to the a, raise it to the power of a, and then you come around and you set it equal to a. Okay, so you can see the b, a equals to n. So if you remember that kind of circular motion, it looks like actually like a sideways heart. That will help you in rewriting. So let's practice rewriting. So here is your first problem. So part A is going to be, where's my problem? It is log, so I'm going to write this down. Whoops. Copy it down here with me. Log base 3 of x equals to 9. So that's the first one. Okay, so I'm going to do the first one here with you, and then you're going to do B, C, and D on your own. So if you recall, we already established our rule. Let me write down what we had over here. Okay, so I'm going to bring this over here to the other page so that you can follow along. So we have the log base B of n equals to a. I think those were the letters. Let me make sure. Log b n a. Yes. And that can be rewritten as b to the a equals n. So we're going to take this and write it as an exponential. We're going to write it like this side. So if you kind of take that one way that I was telling you, let's use the color, let's use blue or whatever you want to call that. You start with the base, which is the subscript, and you go here to the 9 and you wrap around and raise it to the power of this one. The way you're rewriting it is you're saying 3 to the 9th equals to x. And that's you writing it in exponential form. So I want you to practice this technique by rewriting the following. So I'm going to write these problems down, and you do the problems next. And then I'll give you the answers. So pause the video now, and then we'll talk. Okay, so let's see how you guys did. Check your work as we work along here. So we start here with the base, which is the subscript. Go to our exponent. Remember, a log is an exponent, and a wraparound and set it equal to our power. So you should have written 2 to the x equals 8. On this one, start with your base 3, wrap it around, and set it equal to the power. You should have written 3 to the x equals 27. You start with the 5, raise it to the power of 2, because that's your exponent, wrap it around, and set it equal to y, which is your power. Okay? So that's how you rewrite from log into exponential form. Let's go in the other direction. So here in the next problems, I want you to go in the reverse. The first one is going to be, let's change colors here. Let's work in orange. The first one is going to be y equals 3 to the 4th. So go ahead and write that in log form. And the next one is 27 equals 3 to the x. Pause your video and then come back when you're ready. Okay, here we go. So let's rewrite the exponential into log form. So since we need to write in log form, we obviously need to make sure we write the word log. So let me write that down, okay? The subscript will always be whatever the base is. Right here, your base, okay? It's always a little lower than the line you are writing on. So that's your line. You always go below the line. Your subscript is the base of your exponential, which is this one right here. So I'm going to put that 3 right here. Then you always write the power, not the power. No, yeah, the power, my bad. And that's your y. And then I always know that my logarithm is always equal to my exponent. Well, I know this here is my exponent. Okay, so I know that my logarithm had to equal this number anyhow. And my exponent is a 4. Okay, so one way I like to tell students too, if you always remember the phrase, a log is an exponent, you write the word log. So let's do part B. Write the log is an exponent. Well, where's my exponent in this problem? 27 equals 3x. Well, my exponent is this right here. That's my exponent. So I know that my log has to equal that. So I'm just going to put equals to x. And then I can just put whatever is left over, which is the 27 and the 3. So it's either going to be 27 here and a 3 here, or it's going to be the 3 here and the 27 here. So you have a 50-50 chance. But what you have to remember is that the base of your exponential is what goes here in the subscript. So this is the answer you should have written. Log base 3 of 27 equals x. Okay, so let's use these skills that we just figured out how to do, and let's solve some problems, okay? So let us go to using, let's write in green for a while. So our first problem here in solving equations is the following. So write this problem with me. So let us see. This is written in log form. So in order to solve for x, because this is what I'm trying to solve for, I'm trying to solve for x right there, I need to isolate x. So how do I isolate x in log equations? What you do is you rewrite it in exponential form. So if I rewrite it in exponential form, that means I need to take the base and then go to the 4 and wrap around like that. So when I rewrite it, notice that right off the bat, my x has been solved for. See? X has, that does not look like an x. X has now been solved for. And so now that it is isolated, you can just simplify. 3 to the 4 means 3 times 3 times 3 times 3. And we know that that ends up being 81. So that's my answer. Oops, that was not a very good circle. Let's try that again. Yay, there you go. So what I want you to do is follow along and copy these other problems with me and do these on your own. So here are your problems. Solve for x. So we have b. I lost track of where I was. Here we go. Log base m of 81 equals to 4. And then you have log base 2 of x over 2 equals to 5. And last, log base 2 of 4x equals to 5. So pause your video, work these out, and then I'll see you in a sec. Okay, so let us work these problems out. So for part B, we're solving for m. So let's rewrite this. Remember, we're going from the base to the exponent equals the power. So we got m to the 4th equals to 81. And so you do the math. What to the 4th power will give me 81? Well, you can start with 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Doesn't work. Let's do 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So m equals 3. Okay? Now here's the thing though. Students are asking me, well, what if you have a problem that is not as simple as that in being able to figure out that answer? Well, here's one thing you can do, okay? If I, for instance, I'm going to write this in blue so it's over here to the side. So m to the 4th equals 81. No, I take that back. Let's write our own problem. If I said m squared equals 81, most students totally know how to do that. They're like, oh yeah, to solve for m, I just need to square root both sides, miss, and I get m equals 9. And we know that that's all you need to do. And when this is blank over here, let me show you where I'm talking about. When it's blank in this index number here, that is understood to be a 2. That's why we say square root of 2. So that and that cancels in order to get m to the 1st power here, to get m equals 9. I don't know if you knew that, but that's in essence what you're doing. So what I'm trying to get you to understand is what the approach that you use there is the same approach you would use with m to the 4th power. So if you have m to the 4th power equals 81, in order to solve for m, what you're doing is you're needing to take the square root, not the square root, I'm sorry, not the square root, but the 4th root on both sides. Now, if it's a number other than 2, you have to write the index number, okay? And 4 is definitely not the number 2, so I need to write it. So the 4th root and the 4th power basically cancel each other out, and you're left with m equals the fourth root of 81. Okay, now, if you're trying to rewrite that, okay, and put it in the calculator, what you can do is rewrite it so that 81 is written in an exponential form. So in essence, what I'm asking you to do, I'm going to go to the next page to show you what I'm talking about. Actually, it's like 3 pages over. There we go. If you look down here in the bottom left-hand corner with me, okay, the formula says that if you have a radical a to the m and it's to the nth radical, you can rewrite it as a to the m over n. So when I'm having you do the following, I'm going to go back to that page. Okay, so I'm going to write down the formula over here actually so you'd see what I'm talking about. A to the m, and there's an n. You can rewrite it as a m over n. So with your problem, m equals, you will say 81 to the 1/4, okay? And the reason it's going to be 1/4 is because 81 here has a power of 1 right here, okay? You don't see it, but that's why you write a 1. And then the 4 here goes right here. So if you type 81 to the 1/4, you'll end up with m equals 3, okay? Hope that makes sense. Alrighty, if we get a chance, I'll do some more of those problems. All right, going back to this one over here, log base 2 of x over 2 equals 5. We will rewrite it. So 2 to the, that 2 is horrible. Let's try that again. 2 to the 5th equals the x over 2. 2 to the 5th is 32. Bring down the x over 2. And then to solve for x, we need to multiply both sides by 2. So our x is going to equal 64. Okay, so notice if you know your basic properties of logarithms, it's very quick to set it up and then basic algebra that you're using to solve for the variable. So let's try this other one. Our subscript is our base, so we start with 2. The power is a 5, so we're wrapping around, right? You're still doing that. And 2 to the 5 equals what? The expression after the log. 2 to the 5th is 32. And if I had to solve for x, I had to divide by 4 on both sides to get me x equals positive 8. Okay. Alrighty. So that's how you do some basic solving of equations. Okay. Let us keep moving on. So here's another rule that I want you guys to focus on. Okay. This rule is extremely useful. There we go. Is extremely useful in evaluating functions. Now, one thing I want you guys to notice is that, notice I'm using the word evaluate, whereas over here I was using the word solve, and I want you to see the difference. When you use the verb solve, that has to do with equations. So if you notice each and every one of these problems, this was an equal sign, this was an equal sign, equal sign, equal sign. So I'm going to use the verb solve. But if you come to this problem here, I'm giving you an expression, okay? This is an expression, not an equation. But I still know that this expression has some sort of value to it. So I still say evaluate. But evaluate and solve are not synonymous in math. They do both ask you to find the value, but they are not synonymous. So we're going to evaluate this expression. You don't see an equal sign anywhere. You can eventually put the equal sign in, but anyway, I digress. So I want you guys to try and use this rule, because the rule says that if you can get this number here, the base, and this base value to be identical, whatever is your k value right here, that's what your answer is going to be. So your goal is to get those two numbers to be identical. But I want you to look at right now the problem I'm giving to you. Notice that this number and this number are not identical. I do have a k value, and it's right here. It's blank, and that k value would be a 1, but I can't use this property because these two numbers are not the same, okay? They are not the same. So your goal is to make them the same, all right? Goal is to make same. So how can I rewrite log base 10 of 1,000 where if I write, let me tell you this, I want to keep log base 10, but I want this new 10 right here to represent 1,000. Well, I know 10 times 10 times 10 is 1,000, so I'm going to write it like this. So I replaced the 1,000 with a different way of writing it, and that's 10 to the third. Now, why did I do that? Because my goal was to try and make this and this number identical so that I can have a k value, and let's try that again, so that I can have a k value to isolate. So my answer is going to equal whatever that k value is, and it's a 3. And what does that do? That makes me very happy. So this is what I always do. See the smiley face? I'm very happy because it canceled, if you want to think of it like that. And that is my answer. Okay? So giving you another example here, just off the top of my head, just to make it easier for you to visualize. Let's say I gave you log base 5 of 25. Okay? Right now, I can't make a happy face because my base and this base are not identical, so I cannot say 1. I can't say this answer equals 1. I can't say equals 1 because I cannot make a happy face. Those two numbers are not the same. So what can I do to make these two numbers be the same? Well, I know I have to write log 5. I know I want a 5 here, but how can I write 5 as a 25? Well, 5 to the second power makes 25. So that way, I'm not rewriting anything. I'm not changing the original problem. And now I am super happy because that can disappear because of my log rule. So there's my happy face. And I can say, hey, this is my answer. 2 is my answer. And I'm done. Now here's the thing, okay? That's using this rule that I just taught you. But I want you guys to notice something. If this rule makes you uncomfortable, you can also do it this way, all right? So here's your other option. I would like you to get accustomed to the rule, don't get me wrong, because it's faster, but here's the thing. Our original problem of log 10 of 1,000, we can take the expression that was given to us and say, hey, what does it equal? So what is that equal to? But instead of using a question mark, I'm going to use an X. And now it's a log equation. So now I can use the verb solve. I can solve it by doing what I taught you. 10 to the power of X equals 1,000. So I'm doing that little wraparound thing. And I just ask myself, well, 10 to the what power gives me 1,000? Well, X to the third power. So notice that the answer that I'm giving you right here still ends up being the same as this one. Just 2 different ways of approaching. But notice you're still just finding an exponent value. So So what are we going to do? We're going to have you practice. So here's some problems that I need you to take note of and do it yourself. So let's work in light purple. So here are your problems. So problem log B. So this one right here that I'm writing, you should know this already because we've been working with that rule quite a while now. Log base 3 of 27. D is going to be log base 2 of a 1/4. And the last one is log base A of A to the X. Okay, so go ahead and pause and work these out for me, and then we'll go over them together. Okay, welcome back. Let's work these out. So log base 4 of 1. Hopefully you're ready to remember your rule. That's just 0. You're done, okay? If you wanted to try and work it out, you could work it out like if you said, I don't know what it is, and you wanted to set it equal to x, you could have said 4 to the x equals 1, and 4 to the what power will always equal 1? Well, 4 to the 0 will always equal 1. So x has to equal 0. So that's one way you can do it. But like I said before, you know this rule already, so don't waste time doing all these steps, okay? So I'm going to erase this because that's how adamant I am about you making sure you know the rules, okay? So 0. Log of any number equals 0. And you can look on your formula sheet. I don't know if I'm using the right letter, but the log of any base of 1, the rule says it's 0. Okay, so that is a rule. Okay, next one, part C, log base 3 of 27. So I'm trying to get you guys to use that new rule, okay? And that also is in the list of rules on your formula sheet. I think we called it rule number 6. So my goal is to rewrite this and make this number go in there, okay? So log 3 stays the same, and I want a 3 here, but 3 to the what gives me 27? Well, 3 to the 3rd power gives me 27. So now here is my happy face. I'm happy because it disappears, and so it disappears to tell me that my answer is 3. Okay? Let's just go ahead and do part E here. Log base A of A to the X. We are already happy here because those two numbers were the same. So what is our answer to this one? It's just an X. You're done. All right, so log base 2 of 1/4. What is that going to equal to? So here's a rule that I need to remind you guys of. And I am going to write it over here in the bottom right, okay? And this is an exponent rule. An exponent rule of this 1 over a to some m power is always going to equal a to the negative m power, okay? So what I need you guys to do is to keep this in mind, okay? This rule, the reciprocal of a fraction will always make your exponent negative. For our problem, we have a log base 2, and I'm trying to get this number written with a base of 2. So 2 to the what power would give me 1/4. Well, if I use the formula over here, and I'm gonna draw another line over here to kind of show work. So let's use the formula. I have 1 over 4. But I know 1 over 4 is the same thing as saying 1 over 2 squared. So if I use this formula right over here, I know I can rewrite 1 over 2 squared in that format. What would that be? Well, that would just be 2 to the negative 2. So over here, 1/4 is 2 to the negative 2. So what you can do is just think of the denominator. 4 is 2 squared, but because it has a 1 above it, just put a negative. And so now I am super happy here because I've got the log 2 eliminated. So my final answer is negative 2. Alrighty, let's move on. How do we rewrite this one? Again, looks like it's getting a little bit longer, but approach it like we've been doing it. Take that 2, go here to the exponent, wrap it around, set it equal to the power. So we've got 2 to the second power equals to 2x plus 1, the entire expression. Simplify. I'm going to solve for x by doing what? Subtracting 1 on both sides. And then in order to isolate the x, I would divide by 2. So the answer is x equals 3/2. Okay. A common question has been, can I write the decimal value? Sure, if you want to. I think Delta Math tends to use the fractions, but 1.5 would work as well. Okay, so let us move on to these notations. Here are some notations that I need to bring your attention to as you are getting ready to dive into your homework. So if you see something written like log of 50 and you're like, wait a minute, what happened to the subscript? Is that a mistake? Did they forget to write it down? No, they didn't. If it is blank for a log, that subscript is telling us that the base is going to be a 10. It's understood to be a 10. So for instance, when you guys take not a circle. When you guys see something written like this, you guys automatically read it as square root of 10 because you understand that this is universally accepted to be an invisible 2. Well, that's what I want you to do with logs. Another example, if I said x or 2x and I asked you, oh, what's the power of that x? You guys automatically tell me that the power is a 1. Even though it's not written there, you understand that this is a 1. Same concept, okay? So blank subscript next to a log, that number is understood to be a 10. A blank subscript for a natural log, ln. ln basically means log e. But instead of having to write log e every single time, mathematicians write ln. Okay, so log e and ln mean the same thing. But again, if your subscript is blank next to an ln or log, natural log, you need to know that that subscript is actually e, which is the 2.718 approximation for e. So keep that in mind when you guys are doing those problems. So let us do these last 2 problems, okay? Again, working them out. See that ln right there? So tell me, what is that subscript here? Okay, we just talked about it. The subscript is an e. Even though I didn't write it out, it's an e there. So if you have to write it in to kind of help you remember, that's fine, okay? So what I'm trying to get you to do is you need to rewrite this so that we can do that little smile rule. I like to smile, so it tells me I've simplified everything. So here is my ln, okay? And I know I have an invisible e here. I'm going to just leave it there. And I know I need another e here so that I can do my smiling face. So how can I write that e if this is what I'm supposed to be writing? How can I rewrite it? Well, we already talked about that. Remember I told you 1 over e thirds means reciprocal. So I'm going to rewrite this whole thing as e to the negative 3. So I'm going to put the negative 3 right here. E to the negative 3 is the same thing as 1 over e to the third. And so now I am happy to get rid of that. So I can now say my answer is negative 3. And you're done. Let's look at this again. This last one. Again, manipulating it. I have a log. Sorry about that. I have a log. And I know I want an 8. This here never changes. Notice how every single time we did it, those never changed. You just wrote it down. But what I want is I want this, what am I looking for? Another color. I want this number to be an 8. Okay? So I need to figure out a way of writing this as an 8 to the something power. Okay? So how do I do that? So what you're going to do is remember that I gave you a formula. AM over N equals AM to the nth root. So let us rewrite it, okay? Let us rewrite that. So let me erase this here because it's kind of noisy and it's confusing us. Let me go back to write it in. So the problem was, oops, I'm almost forgetting what the problem was. The 5th root, yikes, the 5th root of 8. So let's follow here. So I have my A value for my problem is an 8. I need to know what my M value is. Well, my M value for 8 here is an invisible 1. So I have to put a 1. And then what's my N value? Well, my N value is this number right here, and it's a 5. So how can I rewrite this entire thing? Well, let's go do it over here. I'm going to write the 8. I'm going to write this number, which is a 1, over. I'm going to write this number, which is a 5. So I'm following this rule up here. AM over N, okay? And now I am super happy because this here makes me happy and tells me I can go ahead and write 1/5 as an answer. And writing in yellow is never a good idea. Okay, so we are done. Hope this helps you get through your assignment. And as usual, if you have any questions, reach out. Thanks for watching.